Hi ladies and gentlemen, this is Mr. Green and we're continuing on with another lesson in Algebra 1. We're getting close to the end of the semester, so these lessons are getting a little bit more important every time, okay? Got to make certain you're understanding them. If you have any questions, you ought to be coming to tutoring. Make certain you're getting there if you need some help, okay? Because that's what I'm here for. What we're looking at today, you know, we see a lot of things in life that are parallel and perpendicular. Parallel things like train tracks, parking lines, equal signs, they're all parallel. Streets, well, some streets intersect and they're perpendicular. Grid lines on a graph, okay? The sides of rectangular frames, they're perpendicular. And when you compare the slopes of, we're going to compare the slopes of parallel and perpendicular lines today. Very important lesson. Now, I know you think about train tracks and they go on. You look at these and you go, but they intersect way out here, Mr. Green. No, they don't. That's just an optical illusion. They're always the same distance apart. That way, trains don't have any problem staying on the track. You look at lane lines in a swimming pool. These lane lines are going to be parallel to each other. They're never going to get any skinnier. It doesn't get harder for the swimmer to stay in the lines as they get closer to the end. They're still the same length, same width all the way down. Okay? You look at the prongs on the end of a plug. Well, they're supposed to be parallel unless you've bent them, and then they might not be, but they're supposed to be parallel to each other. Skiing, yeah, you want to keep your skis parallel to each other. Otherwise, they cross them, and not good. Slow down really badly. Lines on your paper, those are parallel lines. And look at the bricks. Bricks in a house are parallel lines going back and forth. How about perpendicular lines? Well, you know what? I see perpendicular lines right here because these two lines are crossing. They're saying it's a perpendicular intersection. Okay? You look at the tiles on this floor. You can see the white tiles. They're perpendicular to each other, aren't they? And the sides of the rectangles or the squares they're all perpendicular. Look at this pretty art up here. It's perpendicular. Even some of our national pastimes, like baseball, you draw a line from home plate to second base and a line from first base to third base. They'll intersect in the middle. Perpendicular. Okay? They're perpendicular where they intersect in the middle. Great type of situations that you might have to know. Okay, how do we use this information? If two linear equations are parallel, they got to have the same slope. Well, what do you mean, Mr. Green? Well, look at these. There's an equation for this train track, and there's an equation for this one. They're both linear equations, and they're parallel to each other. Their slopes are the same. Guess what? That means their slopes are the same. Yes, their slopes are the same. That means if I'm asked to write an equation of a parallel line, all I got to do is look at the slope. It's the same as the other one, the new one. Not a problem. How about perpendicular lines? A little bit more difficult. Let me try to explain. Two perpendicular lines, their slopes product will be -1. Let's make it a little bit easier for you so you understand it. If the slope of one of them is a over b, the perpendicular one would be negative b over a. Yeah, flip it over and make it negative. That's what perfect perpendicular means. Two kittens laying on a couch right here, making a perpendicular corner right here. Okay? Yeah, flip them over and you make one of them negative. Cool? Okay. What are we going to use this for? I could give you the equation of a line and ask you to write the equation of a new line that is parallel. All you got to do is look at the first line and see what its slope was, and your new line is going to have the same slope. It might have a different y-intercept, it might have a different point that you're going through, but it would have the same slope. That's half the problem right there. What if I asked you to write one that was perpendicular? Well, you know what? It's actually not that difficult to do. Let's try a few things here just to see what we're going to get, okay? If I asked you if determine if the pair of lines here are either parallel, perpendicular, or intersecting. Well, if they're parallel, their slopes are going to be the same. Is -2 the same as 1/2? No. So this one's not parallel. So let's try and see if it's perpendicular. Let's say -2 times 1/2. Well, -2, that's -2 over 1. You multiply straight across, you get a -2 over a 2. And that's equal to a -1. They're perpendicular. Okay, perpendicular. That's what the symbol here means. It's perpendicular. Cool. That's easy to do. Let's look at this next one over here. 4/3 and -3/4. Are those the same fractions? No. Let's multiply them together. See what we get. 4/3 times -3/4. Well, that's going to give me a -12/12. That's equal to a -1. Perpendicular again. That's nice. Okay? Let's look at this one. Let's see here. 2/3. Is that the same? Wait a second. This one's not in slope-intercept form. It's in standard form. Well, that's not really a problem because we can add 6x to both sides of this equation, right? And get 4y is equal to 6x x plus 12. And then we can divide by 4. Okay, and we would get y is equal to -6/4 plus 3. 6/4, that's my slope. I can multiply this one times -6/4. Fraction multiplication, I know. 2 times -6 is equal to -12. And 3 times 4 is equal to a 12. -12/12 is a -1. This one is perpendicular. They're perpendicular lines. Okay? One more over here. We've got -2 and 1/2. Well, -2 times 1/2. Make that over 1. That makes it a -2/2, which is equal to -1. This one is perpendicular too. All of these were perpendicular. I figure you can figure out what the same looks like, can't you? Okay? Well, what would we do if it wasn't -1 that we were getting in each of these? Okay? Oh, wait a second. I made a mistake here, didn't I? When I added 6x over here, this is a positive 6 divided by 4. Positive 6 divided by 4. That makes this a positive 12 divided by 12. That's a positive 1. These aren't intersecting at all. These are just intersecting lines. Okay? It's not perpendicular at all. I knew there was one here that had wasn't perpendicular. Okay? Do you guys see what mistake I made here? Negative sign. Catches even me sometimes. Okay? Cool. Well, let's go on here. This question is asking us to find the slope of a line that is parallel. Let's do parallel to begin with. Parallel. A-R-A-L-L-E-L. You know what? I'm a terrible speller. I like to use the abbreviation. It's just two straight up and down lines. That means parallel. So what would be the slope of a parallel line? It would be where m is equal to 4. Where'd the 4 come from? Right there. It has to be the same slope. And the second one would be m is equal to the number in front of the x. Don't forget the minus sign. -2. Why? Because this could be written as -2x plus 5. I swapped the order there, right? The -2 is the slope. So this one would be -2. How about this one down here? Ah, the 2's trying to trick you, isn't it? Let's just divide by 2's everywhere. Y is equal to 3/2, x minus 4. Well, that 3/2 is my parallel slope. So now let's try to find the perpendicular ones. Perpendicular. Perpendicular. Once again, that. So a perpendicular slope to this one, to 4, is going to be m equal to, I'm going to put it, flip it over, make it 1/4, make it negative. That didn't seem too difficult. So let's find the perpendicular one to this -2. Put it 1/2, make it negative. Wait a second, 2 negatives make a positive, that'd be 1/2. Okay, this is working out easy. So this last one down here, 3/2, flip it over, 2/3, and make it negative. I'm not even having to do any calculations here. I'm just writing them down, aren't I? Doesn't seem that difficult. I think you guys can figure this one out. But if you need help with it, tutoring's available. I'm there for you guys. Look forward to seeing you next time.